So hi guys, Pete Shersby here from Make or Repair, and today we're going to take a look at an OsziFOX little handheld oscilloscope probe. So I'm really just doing this because I'm tidying up the incredible mess of the laboratory at the moment, and just working through some of the small items. This one I'm thinking either I might use it as a little logic probe, which someone has suggested to me, little digital logic probe, or I might actually just repurpose the case and the display for some other reason. So let me know what you think. This is for the zero offset. In fact, it says that zero level. Here we've got a select switch and a menu button. Menu select. I think this one is AC, DC and ground coupling for the probe tip. This one I think is the voltage selector, like 1 volt, 10 volts, 100 volts, that sort of thing, and I think those are actually the ranges. I'm saying that because this is a 100 volt peak on the tip. Okay, here we've got a little socket, but that is the one wire serial that would output a stream of data from this to a connected PC. I don't have the software. This would be Windows 3.1 software anyway, so what's the point? And then in the end, we've got a normal DC power adapter on the back. And it's a center plus, so that's helpful. It's marked that on there. You probably can't see that on the video. We've got a ground pin and a trigger pin that can be connected, and I'll have to find a bit of wire to stick in those because I certainly do not have the original connectors for that. But I'm sure I can just twist the ends of a bit of wire and make adequate contact. All right then, let's power it up just to see if it works. So there we go, WTT Whitting, which is the make. Menu. Oh, there we go, OsziFOX version 3.0, 1995. So if you had any doubts, there we go. That's what we've got. And then, yeah, we're onto the scope screen. Okay, it's entered that. Okay, time base 100, 0.5 microseconds, 1 millisecond. 50 nanoseconds is the fastest. I'm not really sure what that 50 nanoseconds relates to. Is that 50 nanoseconds for the whole window? And this is, what is this? This is about a 16 by 32 LCD, something like that. It is backlit. It probably doesn't show up too well on the screen. It's not bad. I've got quite a lot of light in here because of course I'm videoing. But overall it's not bad actually to see. It's quite clear. Okay. Quick look on the menu. Time base, trigger, backlight, scope. Okay, so let's go down to scope and select. Yeah, and DVM. Apparently it's 0.5 volts. Okay, so just switch that over and it says it's grounded. And now we're on AC. And now at 0 volts DC. So let's stick it on its own. I'm trying to hold this in the screen. So I'm going to stick it on its own 9 volt battery. And it reads 0.47 volts, so that's not much use. But I think it was giving a, yeah, it's got an over voltage warning little arrow in the corner. 0.0, well, let's try that. If that's 10 volts, 4.7, and we're still over. So that must mean it must only scale to about 5 volts. And we've got no decimal points now. And there we go, 9 volts. Okay. Cool. I had a little look on the internet, and one of the things suggested that this was a 20 megacycle 6-bit DAC in here. Given the resolution, I might believe the 6-bit part of it. I mean, 6 bits is obviously sufficient to sample for the vertical resolution on the screen here. But anyway, I don't know that for certain. Okay, so we've seen it generally working. I'm going to just grab a signal source now, piece of wire, which I'm going to stick in the ground if it'll go in. Yeah, there we go. Oh yeah, perfect. perfect fit, made for it really. Again, hopefully I can put that back in the display. It's actually quite tricky for me to position these because for some reason, because I've got the display on the camera turned around so I can read it from the front, and rather bizarrely they've set it up to act like a mirror, which means I have to do everything in reverse, and it's really confusing to me. Right, okay, let's just bring the, I might just zoom this out a little bit just so we can see what we've got going on. So we've got the wire coming down and round, and here's the ground from the signal generator, which I'm going to turn on. The signal generator is 1 kilohertz 4 volts peak to peak with no offset. Okay, so there it is. 1 microsecond, 5 microseconds. Oh, we're beginning to see the shape of a waveform now. Okay, one waveform, not very stable. Trigger auto, positive internal, that'll do. I'll leave the level alone. And there we go. A stable waveform. Now, unfortunately, I can't check what the time base was without changing it. 0.5, 1 microsecond, 5 microseconds, 10 microseconds. So I think that was 50 nanoseconds. So it looks to me like that means the entire width of the screen. Okay, let's change the frequency a bit then. We go up to 3 kilohertz. And now I'm going to put something a lot bigger in. 1 megahertz. Okay, so that's interesting. So at 1 megahertz, this is now just a gentle curve. So clearly that is an aliasing problem with the scope. 50 nanoseconds is displaying it. Which is kind of what you'd expect, I think. And that's all right as well. And then it breaks up there, which is kind of what you'd expect. It's just flicking around there, but you'd really expect it to be just a load of vertical lines at this point. Yeah, and now it's measuring it as a very low frequency, which means that it's actually chopping pieces out of each piece of signal and assembling them. This is just crap, really. It looks like a perfect signal, but I should be able to just so I'm going to change that by 1 kilohertz. Oh, and there you go. So this is a 1 meg signal, and I'm adjusting it by 0.1%. Bang, completely different signal it thinks, and now it's lost the signal completely. That's just kind of random all over the placeness, and there we go. So it's clearly not actually showing a trace of that frequency. It just happens to be the frequency it's chopping it at and the frequency I'm generating are by look producing a stable signal. So let's just let's take a look at a logic circuit then, because this was the suggestion that actually we use this for logic purposes. So there we go. That's our 1 megahertz signal. Switch it down to 500k, and we're sort of triggering it. We can see it at least up to 2 megahertz. Looks like how you're doing. And there we go. That's a 4 megahertz digital signal. And it's having problems with that. So hopefully that's given a little bit of a view as to what this device is like. I've got to be honest, other than seeing whether a signal is present or not, it's pretty useless. Okay, let's take a look inside. So I've been noticing as I've been doing this that it's clearly got the screw missing, because it just does that. Let's take it apart. Oh, well, there we go. That was easy. So I quite like the case. It's quite a nice shape. It's well tapered towards the probe point. Let me unplug the power, get all this cable out of the way, and I'll just zoom out a little bit so we can just see what we're doing a bit better. Okay. So it came out, there were no screws holding the board in. There was in fact only one screw hole in the entire case, which is just here. And it's got a label stuck over it. Yeah, and oh, yeah, there we go. There's a clip holding the LCD in place. So yeah, so that's not bad at all. I mean, design-wise, you can't get a much quicker and simpler construction. That literally just sits snugly into the case. I mean, it doesn't wobble at all. There's no movement there. It fits very, very nicely. I can't quite see what the retaining parts are. It might just be the sides of the case, but I don't think so. I think there's a little bit of extra, oh yeah, there's a tiny bit of extra moulding just in the case to help hold off the through holes and all that sort of thing. And in the lid, there's a couple of push down points here and here to push the board into position. There's a retaining point, little well just here for a lump that's on the probe tip. And other than that, a lot of cutouts just to for all the switches to go through. And then there's a clip just here. I don't know if we can see that very clearly. Yeah, there's a clip just here, whose job is clearly just to clip onto the side of the LCD. The LCD itself, there we go. Will that focus or not? Is it going to have problems? Just pull back out a little bit. So the LCD itself, as you can see, flaps around in the breeze. It is held on one end by four, oh, I don't think I can quite get that, maybe just there, yeah. So it's held on by four springy wires at one end, and there is no support at all at the other end. It just flaps around and lifts up. There we go. You should be able to see the four wires, I think, under there now. And it's got a panel on the back, I think, and it's got a blobby chip on the back. Let's lift it up a little bit if I can. So there we go. I'm trying actually not to damage this because I might want to reuse this LCD. I'll see how I feel about it. So 4 wires going into this LCD must mean that it's a serial protocol. It's got a chip on the back of it and a nice little circuit board. So it's clearly just decoding all that on board. Okay, let's take a little review of the board from end to end then. In fact, okay, right, so one photograph. So here we've got an M69AB. So I'm going to go for that being the ADC. I had a look to see if I could find out what the ADC was in this, and I couldn't really find out very much about that. It did take me to a device. It's National or Fairchild. It did take me to a device, but I didn't really think that it was necessarily the right one, because it was only a couple of hundred kilohertz and it was 8-bit. I mean, you know, you could do it like that, running off the trigger and synchronously testing, like in the old-fashioned storage scopes. And maybe it does that. But yeah, and the part number was actually different, so I went from that and it cross-referred me to another part. So yeah, I'm not really sure that was the right part. Around this, there's not much going on. You know, there's no other little ICs buried under there. We've then got an IC further back. Have we got a decent pointer? The pencil will have to do. We've got an IC back here. Let's turn that round so we can see what that is. So that is a ZMD, It's a U1825PC. Okay, and for that I could find nothing at all, and the only other I see on it is just here, and that's just a 5-volt regulator. So we've got some unknown unregulated voltage coming in here. We seem to have a little bridge rectifier just in case we join it up backwards. Small smoothing capacitor, not very big value. So 4.7 microfarads. Yeah, and there's not much else she wrote really. It looks to be a double-sided board. It might be multiple layer, but I'm not seeing the shade of any traces to indicate that that's so. Got crystal down here as well, and then this wheel is actually an open frame trimmer. So again, not much going on there. These switches will be dual pole 3-way. Yeah, so there's not much on there. Analog digital converter, a little microcontroller, squirting out a signal. Okay, so I figured why not. I'll take a quick look at the digital signals to that display. So I have it started up, displaying the letters WTT. I found the 4 pins on the back of the board because it's easiest to probe them there. And I can see straight away that the top one is ground. Well, there you go. So we've got about 5 volts on one end. We've got 0 on the other. So let's call that pin 1 is 5 volts, pin 4 is 0 volts. Pin 2 is also a stable 5 volts. And pin 3 has got a signal on it. Let's have a little look. So that's 1.25 megahertz that we've got on there. So that certainly must be the clock. So I'm going to just press the, I think it's the select button, just to try and change what's on there a little bit. Yeah, there we go. Now we're getting some signaling going on. DVM. Okay, so now I've got it printing some letters. The letters 0. I don't know if you can really see that, 0.38, and then an AC on the bottom. Let's see what the signal for that looks like. Pop back into run. So again, yeah, we've just got little bursts happening there. The bursts look pretty much the same. We could try and get a serial decoder on this, but and we'll single shot that. Oh. There you go. And just take a little peer at those, just see if there's anything of any interest there. So there's our first burst. Drilling a bit further. Yep, not much happening there. Good look at the actual signal itself. Don't know if I've got the resolution to do this. There we go. There we go. That's what we wanted to see. Piece of actual data. Scroll along, it could be quite a while before we see the next one. Here's another piece of data that's different. Yet another different bit of data, and so on. So that's good. So I'm calling it a day at that. Clearly there's a nice serial protocol there. I'm not going to bother trying to join up a decoder and work out exactly what it is. It's really just not worth it at this point. But hopefully that's given you a taste for the OsziFOX probe. I've pretty much decided that I'm going to rip out the internals of it and replace it with something else. Perhaps something that could be used on a series of boards that need testing and can have some pass-fail markers on. So if you've got any ideas, let me know. But certainly maybe I'll drive that LCD, maybe I'll just replace it with a board of LEDs or something like that. Anyway, if you've enjoyed this, please give it a thumbs up, and if you haven't already done so, please remember to subscribe, and I'll see you next time. Take care.